Alright, so, what is the most obvious variable, D or M, that we think we should eliminate?
D.
Yeah, I got smaller numbers. This is already a 4, the least common multiple for 2 and 4 is 4. So I only have to multiply one equation here. I would need to multiply equation 1 by what? By negative 2. So let's multiply equation 1 by negative 2. And that becomes negative 4D, negative 250M equals negative, check me on that, 191.50. You guys have the calculator. Does anybody agree?
Negative 1.
Oh. Okay. Equation 2, like we said, we only have to multiply one equation, so it will stay the same. Alright, the reason we did that is to eliminate D, and we're going to do what coming down? Add coming down. So negative 250 and positive 350 would be 100M is equal to 226.5 minus 191.5 would be what? What? 35? Alright, divide both sides by 100, and we can leave a fraction that we reduce by 5 3500ths. We can reduce both of those by 5, or we can make a dynamic decimal, 0.35, right? Let me ask you a question. In my ordered pair, which I will have an ordered pair, if I get one variable, I will get another. And I will show you what I mean by that when we do another example. It's a couple more examples in a minute. But if I get one variable, I know I'm going to have a consistent independent system. Now, where does M go? M for X or M for Y?
Y.
Why do you know that?
Because it's bigger here.
Alphabetically, right? Alright, Lane?
I got confused whenever you got to, like at the 100M equals 35 over 100. I got confused right there.
Okay. Do you know where the 100 came from? 350 minus 250? And the 226.50 minus the 191.50 gave me 35? And then I had to solve for M, so I just divided by what I had multiplied there, divided by 100. Good deal? Alright, now we have to substitute back in to either equation, doesn't matter at all. So if I pick the first equation, 2D plus 125 times, I can do 7/20ths or I can do 0.35 equals 95.75. Would somebody multiply this for me? 43.75 equals 90. This should be 95.75, right? All right, we're solving for D. $52 divided by 2. D is 26. Now tell me, why is it better to do the elimination method than the graphing method with this problem?
Because you have a fraction or a decimal.
Wouldn't have any idea. We'd have to estimate. We might even call it, oh, it looks like about 1/3, because it would be real close to that, wouldn't it? We wouldn't know unless we did an algebraic method. Does anybody have a question about what we did? Yes, ma'am.
How'd you like tell which, like the X and the Y?
X and the Y, okay. When I look at my two variables, the one that comes first alphabetically is X and the other one's Y. Anybody else? On the top of page 334, we have 2x minus y equals 7, and 5x plus 4y equals 11. All right, now, in the directions, we're just practicing, so eliminate X. See if you can eliminate X.
I thought it's been recording this whole time.
Read it back.
You like add or subtract those?
Good. Now plug that -1 in for either equation.
Which one?
It doesn't matter. Not at all. All right, now we've got minus y, so minus a -1 would be plus 1. That's it. Now solve for x. And so your ordered pair would be, good job, consistent, independent. You want one of them to be +10 and one of them to be -10. So I could have multiplied, or she could have multiplied equation 1 by +5 and equation 2 by -2, just as long as one of them was positive and one of them was negative. It really doesn't matter which one. All right, does anybody have a question? All right, next we're gonna take the same problem and we're gonna eliminate y, which is probably what you wanted to do anyway, because it was more set up to do that. So 2x minus y is equal to 7, and 5x plus 4y is equal to 11.
Do we do it on the next page? Like the next?
Is it the next? I don't know where it is in the
Is it
packet.
someone knows?
Why? Good job. Consistent, independent. All right, does anybody have a question? How do you feel about, we need more practice?
Yes.
No.
We do? Okay.
I mean, I don't really need more practice. I just like doing this stuff.
Well, that's great. All right, let's look at the B part. 3, can I make these X and Y? Would that be okay for the A and
That
B?
is good. Please.
Minus 2y equals 6 and 5x plus 7y is equal to 41. This is saying to eliminate x. it's giving you direction. So what is the least common multiple for 3 and 5? 15. It does not matter which one you make positive and which one you make negative. If I make this one positive 15 and that one negative 15, or vice versa, it doesn't matter. So let's decide together so we all do it the same, nobody gets confused. Let's multiply equation 1 by what?
Negative 5.
5.
Negative 5.
Doesn't matter. So we multiply equation 2 by negative 3. All right, see how that goes.
No, really not.
I'm so rude.
Can I get it?
You just Yeah. So I know that.
And consistent independent. That's it. All right, let's do the same problem on the next page and eliminate y.
Still recording.
We're gonna still keep the x's and the y's. does anybody have a question about that? Alright, what's the only kind we've done so far? Consistent, independent. Alright.
Oh gosh.
Can anybody just tell by looking what you suspect we're gonna get here?
You're gonna look at Y and the X's are gonna be the
Perpendicular.
same.
Perpendicular.
We're gonna be able to
Parallel.
eliminate
X and the Y.
both
Oh,
variables.
sorry.
That's how all inconsistent systems and all consistent independent systems will do every time. The only difference between them is with an inconsistent system, these constants will not cancel. So you're gonna get a false statement. And what do we always say when we get like 0 equals 47? What do we get with any false statement? What do we say? No solution. So those lines were definitely parallel if they had no solution, right? And the system was inconsistent. On the other hand, if the x cancels and the y cancels and the constants cancel, you end up with 0 equals 0, which is a true statement. And what do we have? What do we say every time we get the reflexive property, 0 equals 0? All real numbers. In other words, what we're saying here is we have an infinite, since we're dealing with systems of equations, we have an infinite set of solutions. And do you remember how we would write an infinite set?
Consistent, dependent.
With the equation
X,
in the
Y.
set symbol? Yes,
Okay.
right. Alright, so it doesn't really matter whether we eliminate x or y here. We need to multiply equation 1 by negative 2. No matter how you're looking at it, this particular problem, that's how it's going to work out. So equation 1, that's going to become negative 4x positive 2y equals 2. Equation 2, we're going to keep the same. And you're exactly right. Both of these are going to cancel. Eliminate x, eliminate y. We end up with a 0 equals 6. Remember, add coming down, right? And so that's a false statement. There is no solution. These lines will be parallel if we use the graphing method. It is an inconsistent system. That was shorter than graphing one, right? To see parallel lines, it was much quicker. These are, to me, this is quicker than getting a consistent independent system because you have nothing to plug in.
Yeah.
Right? All right, does anybody have a question about that? All right, again, we've got a system of equations that are in standard form. If they weren't, we'd need to put them in standard form. But whether we wanted to eliminate x or y, we'd end up with the same thing. We need to multiply equation 2 by what?
Negative 3.
A negative 3. Equation 1 is going to stay the same. Equation 2, negative 3x plus 6y equals 12. And then everything eliminates because they're all opposites. The x eliminates, the y eliminates, the numbers here, the constants eliminate, and I get a true statement, which is the reflexive property. And so I can say, oh, okay, well, I have an infinite set of solutions. And it doesn't really matter which one of these equations that I plug in, which one would you say is the reduced one?
Minus 2y equals negative 4.
Right. Could we have looked at this problem at the beginning and seen that equation 1 is a multiple of equation 2, and now we're going to have a consistent dependent system? Either equation you write here is a solution, and this is a consistent dependent system. Do you guys remember when we were graphing and we would have one line lying on top of the other line and we would just show double arrows? That's what it's saying here. That whatever this line was, you know, I didn't try to even graph that line, but whichever line this was, every point on that line is a solution to this equation and to that equation.
Why didn't we learn that yesterday?
Huh?
Why did we learn that yesterday? That
We
was
did when we
simple.
did the graphing method in lesson 1. It's the
Ah,
same thing. We're
gotcha.
doing the same thing when we're with the graphing method. We're going to do the same thing when we do the substitution method. It's just different ways.
This is my favorite.
Elimination, I like it too.